Hello, I'm Anund. I work at Atlassian. I'm going to be talking about defining multi-tenant access controls for a cluster and our experiences therein. First, some definitions. When I talk about multi-tenancy, for us, what that means is team-centric idea. The team has access to a piece of a cluster. It's isolated from other teams. It's almost a namespace, but it's a little bit more. When I talk about our clusters, we run clusters internally ourselves from the ground up, so some of what I talk about today may not be accessible to those of you working in managed clouds. Our clusters, we have multiple clusters. They all run in isolated locations, and our teams can pick where to put their resources. We try to work on a very limited restriction basis. So they try to let them do whatever they want within the namespace, and then force anything they try to do outside of the namespace back into their section of the cluster. We've also gone pretty much all in on defining the entire PaaS API inside the Kubernetes API through its extension points. So for our existing PaaS, the thing that we had to move from lets users deploy their service and its resources in various availability zones in particular regions in dev, staging, and prod. We moved that to Kubernetes. It's pretty much the same, only now it's namespaces. The resources, allowing them to create their own objects, provisioning the same resources, and still doing it in separate clusters in dev, staging, and prod. I'll talk about some of our use cases. The very basic use case, just to start it off, giving users access to the cluster. For us, this means running a 2FA challenge before we generate a token before they actually get to do anything. We need to extend that to their team. Hopefully their old team can interact with their piece of the cluster. We have to let their CI come in. We also have to let some existing automation tooling and external services be able to talk to the cluster using, for the most part, what they already use for internal service-to-service communication. This all needs to be chunked into a particular piece of the cluster, not the whole cluster all by itself. And at times, we need to be able to deny the contents of requests based on the contents of the object that they're submitting, not necessarily just what RBAC lets us do. So, how do we let users in, let their teams in, and let their CI and automation in? Following on from that, how do we let teams create their namespaces? Since that's how we have to tie all of the permissions into that space. How do we deny access based on their requests, contents of the requests? I'll be talking about these ones individually. In order to let users in, they need to properly authenticate. In order to do this, for the most part, we define a set of static RBAC roles inside Git. And for the more sensitive things, instead of static RBAC role bindings. All of these deployed to the clusters. This works for our admin accounts. It doesn't work so well for teams, especially when the teams can come in and define their own namespaces by themselves dynamically. This case here I'm familiar, it's just a basic example of an RBAC role. For this talk, I'll be highlighting important things in green. This is the role. It lets anyone who can assume it get and list one of our internal custom resources. That's associated with the binding. In this particular case, it's just some user. And again, that only really works for admins. It doesn't work a whole lot for teams. I'll talk about how we go from there to teams. For the most part, this is pretty much just associating a group as the subject of the role binding. For us, it means pulling groups out of ldap and associating those with RBAC roles inside role bindings inside the cluster. As I just said. One of the things that comes up is dynamically generating these role bindings every time someone comes in and creates a namespace. We don't really want to be defining the role binding that lets a team into their namespace every time through some sort of manual process with, say, ticketing and Git and pull requests and things. I'll talk Kubernetes as a little bit of an aside. I'll talk about our experience with these roles. Kubernetes itself has a bunch of built-in groups, one of which is system authenticated. You could think about associating role bindings with this role, but it's a bit treacherous. You end up with, because service accounts are also in this group, giving pods permissions you didn't think you were giving if you associate system authenticated with, say, some low-level read-only access. The RBAC definition for role binding for a group, almost the same. It's just a group kind instead. This time it's some team. We also need to let CI into the cluster. We don't want to just let in their users. For the most part, this comes down to service accounts and some sort of service-to-service authentication. At least if you're using built-in primitives for Kubernetes. In our particular case, we have to generate, or we choose to generate a JWT token as part of the build and pass that along as the authorization header towards the cluster. This sort of gets us around the problem of having to manually manage the service accounts for all of our teams, or manually manage the process of revoking all of the service account tokens for all of our teams. The other thing we have to let in, as I've mentioned, is service-to-service authentication. In our particular use case, this is yet another set of JWT tokens, so not something that Kubernetes itself has built-in handling for with no extra configuration. The way we piece all of these things together, the user account tokens, the build account tokens, and the service-to-service account tokens, is with the Kubernetes webhook authenticating token webhook API extension. This allows us to run a little pod inside the cluster that accepts webhook requests, basically of the form, here is a token, please tell me what the users and groups are for this token if this is a valid token. If you go ahead and use this sort of thing, it implies a few constraints on your design. The token itself is going to have all of the context you need to figure out what the groups are for authorization. This may or may not be more or less painful, depending on what sort of control you have on the tools used to generate the token in the first place. As a consequence of RBAC's additive permission model, this also means you have to be careful about what group context you put into the token in the first place. If you put in all of the groups a user is part of, all of your sysadmins are now always sysadmin. They are never anything else, even if they want to be something less. Once we got authentication out of the way, we need a way to associate the RBAC roles and authorization, the RBAC roles that form the authorization, to a particular team's piece of the cluster, or mostly a namespace. For us, we use a custom resource, names for lack of a better term, the namespace creator. It does two things for us. When it's created, it generates the namespace object in the first place, and then it fills in all of the associated role bindings in this particular case needed to let users come in, particular team enter the cluster. These are just bindings that we're creating dynamically. We don't actually create any roles. The roles themselves, again, are static. The custom resource itself is cluster scoped. This has problems, or we have problems with RBAC. RBAC itself doesn't let us say, only this team can create this particular cluster scoped object, and we would like them to come along and create it when they're ready, rather than pre-create it for them with some sort of blank data. RBAC almost has enough tools to work around it, and the way we've pieced together a mechanism to do this is by combining two extra features of RBAC. One is resource names. Normally, if you associate resource names, the resource names field to a cluster role, that cluster role will only apply to a particular object. Unfortunately, that only works for creates, updates, deletes, and patches. It won't apply to, it doesn't apply to create at all. It only applies to updates, deletes, and patches, and gets. So if you want to use that mechanism to limit creation, it won't work. The other piece that we use to try and work around this is RBAC's ability to define custom verbs. We can define a cluster role that uses a custom verb associated with a resource name, and then use a subject access review request to figure out during a create whether or not the incoming user has enough permissions to actually create the object using this custom verb as a proxy. One of the other things that defining namespace creation via an intermediate custom resource allows us to do is sort of lock that process down behind a bunch of business rules. Simple things like saying you can't clash with other namespaces, other teams' namespaces, and more complicated things like even though the namespace cube system is not inside our list of teams, you're not allowed to ask for cube system itself. This is an example of what the role binding looks like when we the role looks like when we try to generate it with a particular team and the custom verb claim in this particular case. If you can associate this role with a role binding, say for a team, you can then use the subject access review API to say, does this user, given the content of the original request, have access to claim this particular resource? And of course, the binding itself is very straightforward. It just says, bind to that thing as this team. One of the things we have to note before I go too much farther with this, during the process of role creation, if the service account that's managing the permissions of this process is running inside of the cluster, that service account needs to have the effective permissions of any bindings that it creates. If you're not careful about the sort of permissions you want to let teams have within their namespaces, that service account can sort of accumulate something near to an admin or sysadmin level of permission. It's just something to be careful with. I talked about limiting the creation of our top-level namespace object to a particular team. In order to do that, we have to know that a team wants in the first place, since teams come and go inside the company. The way we do this, mostly to keep things consistent between the old PaaS and the new PaaS, is by running an API server as a bridge between the pre-existing service we have for this process of namespacing teams or getting fresh names for teams and the new cluster. Lets us bridge. Having an API service like this lets us bridge the experience to be as if the old service is running inside the cluster, which is fairly nice and convenient for users who want to generally use just the kubectl API and not some sort of extraneous other command every once in a while. One of the other things that implementing it as an API server helps us do is avoid some sort of manual synchronization task that would say, talk to the old service, read all of its information for its entire list of teams that should exist, and then dumping it into the cluster as some sort of config object or secret into a particular namespace somewhere that has to be special. Instead, what we can do is implement watch on the API server, and then anything running in the cluster that needs to know about changes just watches that as if it were any other object. At the beginning, we did this from scratch. We we implemented pieces of the API server contract. More recently, and it is doable, you can use things like kubectl with increased verbosity to figure out who's talking to what and how, and then just work backwards. But more recently, we've picked up using the Kubernetes API server library, moving a little bit lower than what it wants. It intends you to do. Since we don't want to use etcd for storage here, we're using an external service. But it saves us a fair number of implementation steps that we otherwise would have to do. The most notable for these are authorization, mostly making sure that when the aggregated API server talks to our API server, we check that the cert is valid. We check that the cert matches the API server, that sort of thing. It also runs subject access review requests for you as a secondary thing in case someone has somehow bypassed the core aggregated server. And it gives us auditing code for basically free in the same shape as everything else in the Kubernetes auditing system. Yep.
So for access, have you considered using Vault backend?
Vault backend. It's on some of our wish lists. We haven't had a whole lot of time to experiment with, backing up. Have we tried to use Vault to intermediate access to the cluster? I assume Vault can issue tokens the way I've talked about. It's on our wish list for various reasons. No, we haven't actually started to use it. A lot of that has to do with just making the existing stuff work and not having to transition all the existing stuff to something new. One of the other things you have to do after you set all of this RBAC permission up is worry about users creating objects that have global scope. The easiest example of this is if you want to let users create ingress objects, you have to make sure that when they create their DNS names or their backends, they aren't clashing with things that already exist in the cluster. So I'll talk about how we do that. For us, we use validating, well, sometimes mutating, but mostly validating webhooks to bring together the missing pieces of context that RBAC doesn't have. RBAC itself can't look at the contents of the objects, and this is part of the reason why create is not easy to do with resource names. So if we want to reject an ingress creation request based on the fact that the DNS does not belong to that particular namespace or team, we can do that in a validating webhook. One of the things to be careful with, though, when you start to do this sort of thing is not to try and wander into user and group-based authorization inside the validating webhook. If you start trying to write whitelists for user and group-based authorization, you're probably just going to have a bad time. In this particular case, our first-hand experience with this was accidentally disabling the ability for garbage collection to run across some of our custom resources because we hadn't included in the whitelist when we originally experimented with ways to lock down the creation of objects. In our experience, these are the sort of things webhooks are good and bad at. Validating the content of the object, as I was discussing with ingress. This also comes up when you have your own, for us, this also comes up when you have your own resource definition objects for asking for things like, please give me that AWS database over in that other account somewhere. You'd prefer that users couldn't go ahead and steal someone else's resource just by carefully crafting their Kubernetes object, even though they can create them themselves. It's a nice place to perform subject access review requests by proxy. If you want, at this point in time in the call chain, you have the original object, you have the user, they have successfully authenticated. You can now craft your own subject access review requests to say, here is the object, here is the verb, or any other mutations you want to make. Here is the user. Are they allowed to do this? And you can rely on RBAC to actually resolve whether or not that's a thing, or your own custom authorizer if you go that way. Teeny tiny notes. The final thing is fairly handy for, and there isn't a particularly good story for this as far as I'm aware anywhere else in Kubernetes, is returning either more contextual or just better error messages to users. In our particular case, this often comes up with custom resources and trying to define some schema validation errors that aren't Kubernetes default built-in schema validation, which is fairly generic and not particularly user-friendly when it vomits back the entire schema to the user. A couple of things webhooks are bad at. As I was mentioning, user and group validation is not a good thing to do in these webhooks. You end up building your own RBAC system from scratch. Jeez. It's easy to look over there. Silent mutation. It's not a good thing to do. It's not, while mutating webhooks can do more than just add defaults to an object, or for CRD's case, mostly in the CRD case, not in the built-in objects, or add extra information you need to, say, pods. We found it's been particularly bad to remove fields for users. They tend to get fairly confused when the thing that they have in Git doesn't match the thing that's in the cluster and things are missing. They're also pretty terrible at running long, expensive checks. So if you need to do anything fancy in your validation, it needs to be fairly quick because this all happens in line with everything else in a synchronous manner. So you'll slow the whole cluster down, You'll slow the whole user interaction pattern for that particular object down if you're particularly slow in your hook, which is not fun. I mentioned mostly using the Authentication token webhook API to sort of munge all of our tokens into username and group context. There's a couple of other customization options if you're not going with Vault, although Vault has to probably use one of these under the covers. The first one is certs. It's fairly vanilla. It only lets you do users and groups. You have to generate the client cert for the user. The second one is OpenID Connect tokens. This mostly comes up for managed clusters because they tend to be the only way you can get in. Again, it's usernames and groups. The last one is a full-on authenticating proxy sitting in front of the Kubernetes API and chatting with it over via headers. This, like authenticating webhook tokens, lets you add not just user and group information, but also extras information. So if you want to go down the route of writing your own authorizer, because RBAC just won't do it, and you can't copy the sort of workarounds that I've talked about today, you can include extra information via this method, either with the authenticating proxy or with the webhook API that your authorizer can then pick up later and figure out whether or not user can actually do what they're trying to do. If you want to look at if you'd like an example of how to do the token access request pattern thing, although in this particular case it's generating client certs, we do have a project called KubeToken on GitHub that does do this, that does manage the dance of talk to LDAP, figure out what this user is, figure out what teams he's on, then talk to 2FA, figure out if the user is who they say they are, run an authentication dance, again over LDAP. If all of that succeeds, generate a client cert and update kubeconfig with that particular cert so that they can then use that via kubectl. It's not a huge step to, it's not a huge step to expand this to using the authenticating webhook token API. You just sort of split the code in half. Way fast. So in closing, the main points I've touched on today, and hopefully you have some better idea of how they work, is customizing authentication, using your own hooks or proxy or tokens to get user information into the cluster, working around a few of the quirks in RBAC to sort of expand what is expressible to be something a little bit more than a namespace. Using API servers to bring extra context into the cluster so that you can sort of begin to make, this is the role binding, this is the dynamic role binding I need to create in order to let this team in sort of things. And using validating webhooks to mush together the context, the request context with the user authentication context to make a little bit more delicate decision about whether or not someone should be allowed to do anything, along with a few other niceties like giving better username, giving users better error messages. Thanks. That's it.